So Algebra 2, Section 9.3, we're going to graph rational functions. In order to graph rational functions, we need to learn about vertical asymptotes, holes, and then basically doing the graphing part. So holes are also called a discontinuity. Okay, so we'll look at some vocabulary words here. So a rational function basically means you're going to have an expression in the top of your fraction and an expression in the bottom of your fraction. It could be some sort of a polynomial of sorts. And then we're going to have to actually factor these things to figure out what's going on with the function. So we call p of x one function and q of x another function. So we're basically taking two functions and making a fraction out of them. So a polynomial function can be traced without lifting your pencil. Continuity, the ability to draw without lifting your pencil. Rational functions won't have continuity. If you look at both of my examples down below here, my one with asymptotes and my ones with point discontinuity, the asymptote, if I tried to trace it with my finger and not lift my pencil, or not lift my finger, I would have a problem when I got to my asymptote here. And an asymptote, if we haven't covered this already, an asymptote is a line that you get forever closer and closer to, but you can't quite touch it. The one down below with the point discontinuity, it's going to actually have a hole right in the middle of your graph. If you plug this function into your calculator, you won't see that hole because it's a hole at one point, and a point is so tiny you can't touch it, see it, feel it, smell it, or anything. So we've got a hole in our graph. So the difference between the two, an asymptote is a break in your continuity where you've got this line and then you're getting ever close to it, and your function's probably going to go in opposite directions in each way. It might go in the same direction on each side, so you might have a graph with an asymptote and maybe you go the same direction on both sides, getting forever close to that asymptote but never quite touching it. You know you have an asymptote anytime you have a variable in your denominator. So I have x minus 3, so my asymptote will be at 3 because x minus 3 equals 0. You can't have 0 in your denominator, and so x would be equal to 3 at this point. X is never going to be allowed to be 3. So if I actually were to draw this thing fairly close to what it looks like, I would have my x and my y axis. And then I'd have a asymptote sitting at 3. And then my line would be getting ever close to it. And in it is, in fact, what I have drawn there. Okay, so asymptotes at 3. We're getting ever close to it on both sides, but we're never quite getting to 3 because you're not allowed to divide by 3. Point discontinuity, it goes along the same lines, except there's one difference with this one down here. When I got my x plus 2 and my x plus 2, those two actually cancel out and become 1s. Now, when your original function has an x plus 2 in the bottom, you can't have a 0 in your denominator. That cannot equal 0, So x cannot equal a negative 2. And right here on my graph, this is where x is negative 2. But since they cancel out, it's not an asymptote, it's just a hole. So you're going to have a line, basically, y equals x minus 1, with a hole at that negative 2 part. So you have an asymptote if the denominator is actually there, and you have a hole, a discontinuity, if you're going to cancel that out with something in the numerator. And that's the difference between our asymptotes and our discontinuity.